Welcome everyone, my name is Mrs. Latoya Terubini and today we're going to be looking at algebra. The course outline is as follows: translating verbal phrases into algebraic expressions, substituting, adding, subtracting, multiplying, dividing, factorizing, as well as adding, subtracting, multiplying, and dividing algebraic fractions. Let's dive in. The first thing we are going to look at is what is algebra. Algebra is using symbols to represent numbers. The truth is you have been doing algebra from as early as first year and you just haven't recognized it. Okay, something plus 2 is equals to 4. What is the something? What is the unknown? The unknown, the missing part of this puzzle is 2. 2 plus 2 is equals to 4. This is what algebra is all about. Let's swap this box and use an x. If I have an x plus 2 is equal to 4. What is the unknown? What is the missing number? The missing number is 2. 2 plus 2 is equal to 4. As we continue into this course of algebra, you'll begin to understand it even more. Okay, the first thing we are going to be looking at is translating verbal phrases to algebraic expressions. The first verbal phrase that we have to translate is the sum of two numbers. How am I going to translate this verbal phrase into an algebraic expression? The numbers are unknown, and they told us here to take x and y, to use x and y as the unknown numbers. So the sum of two numbers can be written as x plus y. This is how I translate this verbal phrase into an algebraic expression. Let's look at another example. The difference of two numbers. How do I translate this verbal phrase into an algebraic expression? The difference of two numbers, the difference of two unknown numbers can be written x minus y. The difference means to subtract. The product of two numbers means to multiply two numbers. It can be written as x multiplied by y. So the product of two numbers again means to multiply. The quotient of two numbers. If the quotient is greater than 1, it would be x over y. Okay? And if we have to find the quotient of two numbers, if the quotient is less than 1, then it would be written as y over x. Alright, so if we are finding the quotient of two numbers, they want us to divide. Let's look at 9 times a number x. Let's do it in parts. We can do this. 9 times a number x. See that? And 9 by x will give us 9x. Next, 8 times a number x plus a second number y. Let's do it in parts. 8 times a number x plus a second number y. 8 times x will give us 8x plus y. We cannot add 8x plus y because they are not like terms. In algebra, we can only add terms that are alike. Let me demonstrate. If I have 2x plus 3x, I can add this because both terms have x in it. So I will have a total of 5x. If I have 2x plus 3y, I cannot add this because I have two different terms. So 2x plus 3y is 2x plus 3y. Let's continue. If I have 4 times a number x minus minus a second number y, it will be 4 times a number x minus a second number y. 4 by x will give me 4x minus y. And 4x minus y will be 4x minus y. I cannot add or subtract unlike terms, so it remains like this. A half times the product of x and y. 1 over 2 is a half times the product of x and y, x multiplied by y. The product of two numbers means to multiply both numbers. So a half multiplied by x times y will give us a half multiplied by x times y will give us x, y. Half and the half times xy will give us a half x, y. As you can see here, when we are multiplying, we can multiply different terms. Let me demonstrate here. If I have 2x multiplied by 3y, I will get a total of 2 through 3's 6. I am doing my numbers first and then my variables. X times y will give me x, y. So I can multiply unlike terms. Alright, terms that are not alike. Let me give you another example. If I have 5x multiplied by 2y, I can multiply my numbers first. So 5 2's are 10, and x by y will give me x, y. If I have x multiplied by x, what will this give me? X multiplied by x is not going to give me 2x, it is going to give me x squared. Okay, let's continue. 5 times the product of two numbers x and y. 5 times the product of two numbers x times y. So the product of two numbers means that we have to multiply the two numbers. So we have a 5 times, what is the product of x and y? X, y. And then 5 multiplied by xy will give us 5xy. Great. Now we're going to go on to the second part of this course, which involves substituting numerals for symbols in algebraic expressions. So in this question we have x is equals to 2, y is equals to 3, and z is equals to 4. We have to find the values of the following algebraic expressions. So if I was given this algebraic expression, x plus 5, and I was asked to find the value of it, all I do is substitute the value that was given for x. What was given for x? 2. So it's going to be 2 plus 5 will give me a total value of 7. Let's do a next example. If I was given z plus 2, what is the value for z? The value for z is 4. So it's going to be 4 plus 2. The total value of this is going to be 6. If I was given 8 minus y, what is y? Minus y, 8 minus 3. The value of this expression is going to be 5. If I was given 3x plus 2y, what do? I substitute the value for x. I'm going to put the values in brackets, sorry. So the value of x is 2 plus 2, what is the value of y? 3. Now I multiply 3 2's are 6 plus 2 3's are 6 is equals to be 12. If I have 16 divided by x, what is going to be the value of this expression? What is x? 16 divided by 2 is going to be equal to 8. 8 is the total value of this expression. So all we do is substitute and we'll get our answer. If I have to find x squared, what is the value of this expression? All I do is substitute the value for x, which is going to be 2 to the power of 2, and 2 squared is going to be 4. And what is 2 squared? 2 squared means 2 multiplied by 2. Okay? Is equals to 4. Now we're going to be moving on to the third part of this course, where we'll be looking at adding and subtracting algebraic expressions, right? And I must reiterate that we can only add like terms. So let's look at this expression: 9x plus 3y minus 5c plus 8y minus 4x plus 12c. How do I approach this sum? The first thing I am going to do is group my like terms together before I add or subtract. So I'm going to have 9x minus 4x plus 3y plus 8y minus 5c plus 12c. Now that my like terms are grouped, I'm going to add and subtract. 9x minus 4x is going to give us a total of 5x plus 3y plus 8y is going to give us a total of 11y. Minus 5 plus 12 is going to give us a total of how much? 7. Positive 7. Take your time when it comes to your signs. 7z. Okay? Let's look at another example. 15x squared plus 7y squared plus 9y squared minus 8x squared. How am I going to approach this sum? I'm going to group the like terms together, and then I'm going to add and subtract. So 15x squared minus 8x squared plus 7y squared plus 9y squared. The 15 minus 8 will give us a total of 7x squared. And then we have 7 plus 9 will give us a total of 16y squared. And this is the approach to working questions like this. Let's look at another example. So if I have 3a squared b plus 4ab squared minus a squared b minus 3ab squared plus a squared b squared. How are we going to add or subtract the sum? The first thing we're going to do is group the like terms. So as I can see, I have a squared b term here. Do I have another? Yes, I have minus a squared b. So I'm going to group that together. And then the other that I'm going to group together is my positive 4ab squared minus my 3ab squared. Okay? And we only have one term in a squared, b squared. So we're going to write it again, and then we're going to work it out. We have 3a squared b minus a squared b plus 4ab squared minus 3ab squared. And my last term is a squared b squared. So after we've accomplished this, now we're going to add and subtract. We have 3a squared b minus 1a squared b is going to give us a total of 2a squared b. Then we have 4ab squared minus 3ab squared is going to give us a total of positive 1ab squared. And again, 1 is understood in front of our AB in front of this variable, so there's no need to write 1. Hence the reason for me writing AB squared alone. Let's look at the next one. We only have one term in A squared, B squared, so we're going to add it. So it's going to be plus A squared, B squared. And that's going to be our answer. What did we do? We add the terms that were alike. Let's move on. The fourth thing we're going to be looking at in this course is multiplying and dividing algebraic expressions. Now it's important and it is necessary to reinforce a statement that cumulative law holds, right, of multiplying real numbers and algebraic terms. And that is, there is no particular order in which we can multiply real numbers and algebraic terms. Okay, let me demonstrate what I mean. If I have x multiplied by y, the total value of this is xy. If I have y multiplied by x, it's going to give me yx. It's the same thing. Let's do another example. If I have 3x multiplied by 5y, for some immediately we can see that the answer to this expression is 15xy. Alright, but for those who were not able to see it immediately, let me explain. When we are multiplying real numbers and algebraic terms, what we need to do is separate our numbers from our terms so it can be easier for us. Let me demonstrate. So I can write 3 multiplied by 5, and I have been doing it in the previous slides, multiply my numbers first before my terms. So 3 times 5 times x times y. So as we can see, everything is separated, but we're going to get the same answer. So let me multiply my numbers first. 3 by 5 is 15. Multiply by x by y is going to give me xy. And 15 by xy will give me 15xy. And this is our approach to this question. Let's do another example. Let's look at 5y multiply by minus 3y. So what is my approach? I'm going to separate my numbers and my terms. In multiplying real numbers and algebraic terms, it doesn't matter the order in which you multiply the terms. So let's separate our numbers from our terms. So we're going to multiply 5, multiply by minus 3, multiply by y, multiply by a y on this side. What are we going to get? Positive 5 multiplied by minus 3 is going to give us minus 15, and y multiplied by y is going to give us y squared. So we have minus 15 multiplied by y squared is going to give us a total of minus 15 y squared. Now it's important that we pay close attention to our signs. If I have a positive number multiplied by a negative number, what is going to be my sign? A positive by a negative is going to give me a negative. If I have a negative number multiplied by a positive number, it's going to be the same. A negative multiplied by a plus is going to be a negative. If I have a negative number multiplied by a negative number, it is going to give me a positive number. So it's important to recognize this and practice your signs and take your time with them. If I have a half p multiplied by 8q, again another expression to multiply. What can I do? I can separate my numbers from my terms. I can get this: a half multiplied by 8 multiplied by p multiplied by q. what is this going to give me? What is a half multiplied by 8? 8 is a whole number. 1 is understood as its denominator. Alright, so 1 times 8 is going to give me 8, and 2 times 1 is going to give me 2. So I have 8 over 2 multiplied by p by q is going to give me pq. Alright, so before I multiply 8 over 2 by pq, we're going to break it down even smaller. 2 into 2 is 1, and 2 into 8 is 4. So what am I getting? I'm getting 4 multiplied by pq is going to give me a total of 4pq. Let's do another fraction. For those who wasn't comfortable with this, if we have a quarter x multiply by 2y, again I'm going to separate my numbers from my terms. So I'm going to write a quarter multiply by 2 multiply by x multiply by y. Let's work my numbers first. A quarter multiply by 2. Again, this 2 as a whole number, 1 is understood as my denominator. Alright, so I have 1 by 2 is 2, and 4 by 1 is 4. Right, multiply by x and y. And again, I can reduce this fraction in its lowest terms. I can say 2 into 2 is 1, and 2 into 4 is 2. So I'm getting 1 over 2, I'm getting a half. Okay? A half multiplied by xy is going to give me xy. So a half multiplied by xy is going to give me a total of a half xy. Okay? For those who may be having problems with fractions, you will need to take a look at our fractions video. Okay, let's continue. Now we're going to be multiplying, but we're going to be using the distributive law. What the distributive law tells us is that each term inside the bracket is multiplied by the term directly outside. So yes, what we're going to do in other words is working out the brackets. So we have 5 open brackets multiplied by x plus y. Now how am I going to multiply this bracket? The distributive law that I'm going to multiply the term outside by each term on the inside. So it's going to be 5 by x is going to give me 5x plus 5 by y is going to give me 5y. And this is as far as it goes, because as we know, we cannot add or subtract on like terms. Let's look at another example. We have 3 multiplied by 5x minus 2y. So what does the distributive law tells us? We can multiply the term outside by each term on the inside. So 3 is going to be multiplied by 5, and 3 is going to be multiplied by minus 2. So 3 by 5 is going to give me 15x, right? We have minus 2y. Let's look at it in parts. A positive by a minus is going to give me a minus. So I know a minus is going to come next. Right? So a positive by a negative is a negative. Remember we did that. You can go back and look at it. So we're going to do 3 2s are 6 by y. Good. So this is our answer, 15x minus 6y. We cannot subtract any further because we have two different terms. We have an x term and a y term. We don't have two x terms and we don't have two y terms. Let's look at another example. If I have minus 7 multiplied by a plus b, I can multiply this bracket. Minus 7 by a is going to give me minus 7a. Then a minus by plus is going to give me minus. And then minus 7 by b is going to give me minus 7b. Right? Again, we cannot subtract or add minus 7a minus 7b. Right? Let's look at the next example. If I have 4 by x, I'm going to get, if I'm multiplying out this bracket, I'm going to get 4x plus 4 by y is going to give me 4y plus 3 by x is going to give me 3x, right? And again, a positive and a minus is going to give me a minus. Yes, your favorite. A plus by a minus is going to give me a minus. So 3 by y is going to give us 3y. Right, so we just multiply this bracket. What are we going to do? We can continue to add and subtract. Why? Because we are seeing similar, we are seeing like terms. So I can put all my x's together and all my y's together. Okay, so 4x plus 3x is going to give me a total of 7x plus 4y minus 3y is going to give me a total of 1y. And again, 1 is understood in front of this variable, so I can simply write y. Let's look at another example. If I have 13 multiplied by 5r is going to give me a total of 65r minus 13 multiplied by 4 s will give me a total of 52s. And this is as far as the sum can go because I cannot subtract r from s. Okay, so now we're going to move on to our next topic in this course is factorization. Right, so we factorize a set of algebraic terms by expressing them as the product of the sum of their factors. Right, this is basically using the distributive law backwards. Alright, so when we use the distributive law backwards, we are said to be factorizing. Let's look at an example. If I have ax plus bx, how am I going to factorize this? Right? Or ax plus ay. I'm going to look at the common terms. I could factorize out the common terms. So I could factorize out the a. So whatever I factorize is going to come outside. And then in my brackets, I'm going to put what remains. X plus y. Okay, let's look at another example. Before we move on, let's multiply out this bracket. Let's using the distributive law, which tells us that we can multiply the term outside by each term on the inside. So if I multiply a by x, I'm going to get ax plus a by y, I'm going to get ay. And if you notice, you're getting back what you started with, ax plus ay. Alright, let's do another example. Let's factorize another example. If we have 5x plus 5y, how am I going to factorize this? I'm going to take out my common terms. So 5 can go into 5, 1, and 5 can go into 5, 1. So I factorize out 5, 5 comes outside. Do I have anything else that is common? No, I don't. So I'm going to put my remaining terms in brackets. And my remaining terms are x plus y. Now if I have 64a squared minus 8a, how am I going to factorize this? Let's begin with our numbers. 8 can go into 64, so I could factorize out 8. So I can say 8 into 8 is 1 and 8 into 64 is 8. So I just factorize 8, so 8 comes outside. Now is there anything else for me to factorize? Yes, I can see that there are 2 a's here and 1 a here. A squared is simply a by a. Alright, so if I take 1a from this side, factorize 1a from this side and 1a from on this side, I'm going to remain with 1a. So my a comes outside because I factorized it. Now in brackets, I'm going to put what remains. What remained? 8 by a minus 1. Okay? And this is our answer. And again, if we work out this bracket, we're going to get what we started with. 8 by a, 8a by 8 is going to give me 64 a squared minus 8 a by 1 is going to give me 8a. Alright, let's factorize some more. If I have 25x minus 10, what can I factorize here? I can see that 5 can go into 25 and 5 can 5 times, Also 5 could go into 10 2 times. So I factorized 5. The number we used to factorize was 5. So 5 comes outside. Is there any other thing for us to factorize? No. So I'm going to put my remaining numbers and terms in brackets. What do I have remaining on my left side? I have 5x. What do I have remaining on my right side? I have minus 2. Okay, and there we have it. That's how we factorize this expression. Let's look at another example. I have minus 49p squared plus 7p. What can I see here? 7 can go into 49. So 7 into 7. 7 into 49 is 7. What number did I factorize? 7. So the 7 comes outside. Is there any other common term here for me to factorize? Yes, I can see that there are more common terms. P. I could factorize this p, and I could take 1 from this p. Good, and I'm going to put the p outside. Again, p squared is simply p multiplied by p. Okay, so I'm canceling off 1p. Good, I remain with p. Right, so 7p. There is no more terms for me to factorize, so I'm going to put my remaining terms in brackets. What do I remain with? Minus, yes, don't forget your signs, minus 7p on this side plus 1 on the other side. Let's look at another example. I have 5wx plus 10wy minus 15wz. As we can see, 5 can be factorized here. 5 could go into 5 1, 5 could go into 10 2, and 5 could go into 15 3 times. We're working on our numbers first. So what did we factorize? 5. We use 5 to factorize, so 5 comes outside. Now let's look to see if there are any more common terms. Yes, there is a w in each one of these terms. So we could factorize out the w, and the w comes outside. Right? Is there any more? Are there any more terms to factorize? No. There is not 3x, that we don't have 3y's, we don't have 3z's. Okay, so let's put in what remains in the first term. What remains? 1x. Again, the 1 is understood, so I just write x plus 2y minus 3z. And this is how we factorize. Now we're going to learn to factorize. We already did factorizing using the distributive law. Alright, so we're going to go on to factorizing by grouping. So we have ax plus ay plus bx plus by. And what we're going to do, we're going to factorize by grouping them into pairs with similar terms.